Number 1, evaluate the integral x squared plus x plus 1 over x squared plus 1 dx. All right, you will notice that the degree of the numerator is greater than or equal to the degree of the denominator, so we are going to do some long division. So we'll put x squared plus 1 into x squared plus x plus 1. So x squared times what would give you x squared? That would be 1. So then we're going to distribute that to both parts. So we'll get x squared plus 1. Please notice I have to put it underneath the like term. If I subtract, these will go away, and I will be left with x. I can no longer put x squared into x, so that is my remainder. So it went in one time plus the remainder of x over x squared plus 1. Now I'm going to take the integral of both parts. On the left one, the integral of 1 is just x. On the integral of the second one, we're going to do a u substitution. U will equal x squared plus 1. So du will equal 2x dx. Well, I have the x, I just need the 2, so I'll put a 1/2 on the outside. So that will be 1/2, and then this is a du over u problem. And the integral of du over u is ln, so this will be x plus 1/2 ln of x squared plus 1 plus c. And I don't need to put absolute values because x squared plus 1 will always be positive. Okay, number 2, the integral of 5 over 3 minus e to the x dx. When there's only one e in the problem like that, we can go ahead and do e to the opposite. So we'll multiply by e to the negative x over e to the negative x. So in the numerator, I'm going to have 5 e to the negative x. And then in the denominator, I'll distribute that to both parts. And when I do that, I'll have 3 e to the negative x minus e to the x times e to the negative x will be 1. Okay, now I can do a u substitution, so I'll get u equals 3e to the negative 3x minus 1. Du will equal, the derivative of 3e to the negative 3x will be negative 9e to the negative 3x. Whoops, this was not supposed to have, did I do that correctly? Yes, okay, whoop, this did not have a 3 there though. I knew something was funny with that. Okay, so let's just redo that. So the derivative will be negative 3e to the negative x. The derivative of minus 1 is just 0. So I am missing the 3. First of all, I'm going to just pull, since this 5 is a constant, I'm going to put the 5 out front. I need a negative 3 there instead. So then I'm going to multiply by negative 1/3 on the outside. Okay, so now I have negative 5/3 times the integral. This will now be du over u, and once again, this will be an ln problem, so it will be negative 5/3 ln of the absolute value of 3e to the negative x minus 1. And that doesn't necessarily always going to be positive, so we do need the absolute values on this one. And there we go. All right, number 3, multiple choice. The integral of x squared cosine dx equals h of x minus the integral from 2x sine of x dx. We want to find out what h of x, we want to find out what that number there will be. Well, it looks to me, even though this just kind of looks like a weirdly worded problem, that it looks to me from looking at the integral that is going to be integration by parts, so that is what I'm going to do. So if I have x squared cosine x dx, I'm going to let u be x squared. So my du will be 2x, which means my dv is going to be cosine x dx, and the integral of cosine is just sine. And now I'm ready to do my parts, so it's going to be uv, so x squared sine x minus the integral of v du. Oops, I should put a dx there. So this will be 2x sine of x dx. So now if I look at the original problem, notice the second part of the problem matches, which means the first part of the problem must also match. So h of x must equal x squared sine x. So it will be choice B. All right, number 4, the integral of 1 minus 3x over 3x squared minus 5x, and I actually made a typo. This should be a 2, because otherwise this problem does not work. Okay, so this could be a separate the numerator problem, but before I try separating the numerator, I'm going to see if it's a partial fractions problem. So I'm going to see if I can factor the denominator, which I should be able to do. I'll take 3 times 2, which is 6. Don't forget we have to divide out the extra 3. What times what gives me 6, but adds to give me negative 5. That would be negative 3 and negative 2. We'll divide the 3 out of the first one, so this will be x minus 1 times 3x minus 2. So it does factor. So we are going to rewrite 1 minus 3x over x minus 1 over times 3x minus 2. We will rewrite it as a over x minus 1 plus b over 3x minus 2. So we will put 1 minus 3x is equal to a times 3x minus 2 plus b times x minus 1. Now I am going to let x equal 1 first. And if I let x equal 1, if I plug 1 into the left side, I'm going to get negative 2. And if I plug 1 into the right side, I will get just a, and then that will be it. So a equals negative 2. And then I'm going to let x equal 2/3. So if I let x equal 2/3, when I plug that into the left side, I'm going to get negative 1/3. And then equals, I'm going to get negative 1. Negative 1 equals, and then if I plug it into the right side, the a will cancel out, but the b will be negative 1/3 b, which will mean that b equals positive 3. So if I go to rewrite this integral, it's the integral of negative 2 over x minus 1 plus the integral of 3 over 3x minus 2. Okay, this first one is very straightforward, just going to be a simple all on, so it's going to be negative 2 natural log of x minus 1. Okay, this one, since it's not just a simple like x minus 1 or x plus 2, we do actually have to do a u substitution. So u will equal 3x minus 2. Du will be 3. So notice I have the 3 there. So now this will be a du over u problem. And when I do that, the 3 is no longer there because it's part of the du. This is just going to be the natural log of 3x minus 2. Okay, so that I can put those together, I am going to bump the 2 to the power, so this is going to be negative ln x minus 1 squared plus the natural log of 3x minus 2. And then since this is subtraction, we can turn that into division. So my final answer will be the natural log of 3x minus 2 over x minus 1 squared plus c.